Everyone please comment. I mean, is it visible? Audio and video is clear or not? Everyone please comment before starting. Here you can chart only. You cannot I mean say you can chart only. So please comment. Okay, then good. Clear. Okay, better. So let's continue. But it can be more clearer, but that's fine today. And this is enough. So where the question paper? Yeah, let me write like this. Okay, so then let's start. So already I discussed question number 3. I think again let me discuss this question because it was not visible. So question number 3. A projectile is given a velocity I cap plus 2 j cap. This is the velocity given to a projectile. Velocity along x-axis is 1 and velocity along x-axis is 2. So your tan theta is Vy by Vx, that is 2, and equation of trajectory, you know, y is equal to x tan theta 1 minus x by r, and tan theta 2, and range you can calculate by u square sine 2 theta by z, and u square, this can be written as 2 ux uy into z, because ux is u cos theta, uy is u sine theta, and 2 sine theta cos theta is simple sine 2 theta, and u square. So any form you can write where ux is velocity along x-axis, uy2. So just put it the value and you will get the answer. Now question number 4. So in question number 4, you have a block of mass 10 kg. Let me draw diagram more clearly. So you have a block of mass 10 kg, and then a force acting here 3 Newton. This is 45 degree, and a force is acting upward. So the question is, the coefficient of static friction is given 0.6. What should be the minimum value of force act such that the block does not move? So let me draw the free body diagram. 10 z cos 45, 10 g sin 45. Now let's forget about capital F. And if friction is also acting along this direction and a normal force is acting, as it is not moving, normal force must be is equal to 10 z by root 2, and the value of friction force is mu times normal force, that is 0.6 times 10 z by root 2, that is 6 z by root 2 is your frictional force. Okay, now so what is this? 3 plus 10g mean 100 by root 2, and here 6g by root 2 cannot balance this thing, so a force F must act such that it is not moving. That's why net balance is this 10g by root 2 is equal to 6g by root 2 plus F. If you do it, you will get F is equal to 3 plus 4g by root 2. Calculate it and you will get your answer. I don't know the value of 1 by here you will get 3 plus 4 by root 2, 2 root 2 into z. Root 2, you just calculate it and get your answer. Comment me, everyone, please. Clear? Then we will go to next question. Everything is clear, I think. Please comment, everyone. Okay, question number 5. So question number 5. The minimum force required to start pushing a body off a rough inclined plane is F1, while the minimum force needed to prevent it from sliding down is F2. And is F1. Minimum force required to start pushing a body off of a rough inclined plane is F1, while the minimum force needed to prevent it from sliding down is F2. If the inclined plane makes an angle theta, then theta is equal to 2. So next question, let me erase this one. So in this question, they give us tan theta is equal to mu. They gave us tan theta is equal to 2 mu. I think they gave us tan theta is equal to 2 mu. So tan theta is greater than mu. That is tan theta is, when tan theta is equal to mu, that angle theta is called your angle of repose. That angle is called angle of repose. So the minimum force required to start pushing a body off a rough plane. So when a block of mass m is present here, downward mg sin theta is acting. Here mg cos theta, normal force. So and friction is acting this side, but to push it upward, slowly when I increase the force, it will tends to go upward, and when this F is greater than mg sin theta, friction will act this side, and slowly the force will increase, and when it will reach to limiting friction, that is mu times normal force. And now if the force is little bit greater than this plus this, then it will start moving upward. So the first case F1 must be is equal to mg sin theta plus mu mg cos theta. If I apply this much force, then the body will start moving upward. Less than this force, we cannot move this body upward. Okay? Next, they gave us sliding down is F2, while the minimum force needed to prevent it from sliding down. Okay. So again same diagram, but here the force F2 is preventing it from sliding down. Mg sin theta. Here the friction force mu mg cos theta is not sufficient to keep it on rest, because tan theta is less than mu. Tan theta is greater than mu. As tan theta is greater than mu, here if I put in place of mu 2 tan theta, then tan theta is sin theta by cos theta. Cos theta cancel. 2 mu g sin theta. Right now, what they give? Tan theta is equal to 2 mu. That is tan theta is greater than mu. Here tan theta is greater than mu. Yeah. So, if I put in place of mu tan theta, then you will get 2 mg sin theta. So just 1 second. So here mg sin theta, if mu mg cos theta. So when tan theta is equal to mu, this is your angle of repose, and if this mu is greater than tan theta, then this value mu cos theta will be greater than sin theta. Okay, so or let me write mg sin theta is greater than mu mg cos theta. So when tan theta is greater than mu, at that time the body will slide, because where mg sin theta is greater than limiting friction. Okay. So now a force must be act upward to prevent it from slipping down, that is mg sin theta minus mu mg cos theta. So F2 we got na mg sin theta minus mu mg cos theta. Now divide f1 and f2. If I divide f1 and f2, mg cancel. Sin theta plus mu cos theta, that is your f1, and f2 is sin theta minus mu cos theta. Now divide cos theta everywhere. Here also I divide cos theta. Here also cos theta. Again here. Cancel. So tan theta is 2 mu plus mu is 3 mu. By tan theta is 2 mu minus mu is mu. So your answer is, I think, 3 is there, yeah, in option 4. Clear? Next, let's go to question number 6. A light string passing over a smooth light pulley connects two blocks of mass m1 and m2 vertically. If the acceleration of the system is g by 8, then the ratio of mass is, over a smooth light pulley connects two blocks of mass m1 and m2. So next is the direct question, that is, here is a pulley and it connects two masses m1 and m2. Let me take m1 is greater than m2, and they are saying acceleration of the system is z by 8. It is going off with z by 8, and they are asking us then find the ratio of masses. So I know acceleration is equal to, acceleration of this object A is m1 minus net pulling force m1g minus m2g. So m1g minus m2g by m1 plus m2. Now this acceleration they gave us g by 8. So cancel g, m1 minus m2 by m1 plus m2. Now divide m2 here, and then you will get your answer. Next question. A cubic block of size 0.5 meter floats on water with 30% of its volume underwater. What is the maximum weight that can be put on the, what happened? Everyone, internet is clear now? What happened? So is it audible, visible, everything clear? Please comment once, then I will proceed. Okay then, what is the question? Question is here. So a cubical block of 0.5 meter floats on the water, 30% of its volume underwater. What is the maximum weight that can be put on the block just to submerge it underwater? And density is given 10 to the power 3 kg. And its mass is not, what is the maximum weight that can be put? Okay. Clear? Okay. So next, let me erase this. So you have a cubical block and 30% of it is inside the water. 30% mean, let me take, this is 0.7 V naught and this is 0.3 V naught. This is water, and they have given the, and they gave us 0.5 meter, the length of it 0.5 meter. What is the maximum weight that can be put on the block just to submerge it underwater? So I have to put a weight W so that it will submerge. For now, the buoyancy force is balancing the weight. And what is the weight? Density of this material V naught into Z. And what is the buoyancy force? Buoyancy force is due to only this much volume of water, that is 0.3 V naught density of water into Z. So these two are equal. So let me write rho m V naught into Z is equal to 0.3 V naught rho W into Z. So here we get the density of the material is 0.3 times density of the water. So to submerge it completely, that means this much volume of extra buoyancy force we have to balance. How much buoyancy force we have to balance? Now complete. So already this much water, think like this much water is balanced by total weight of this object. Now this much weight of water can be balanced by another W. So this W must be is equal to 0.7 V naught density of water into Z. But ठीक है ना? So now anything given V naught we know 0.5 whole cube. Density of water I know, G I know. Clear or any doubt? Please comment. Doubt means you just comment. Now let's go question number 8. A long cylindrical vessel is half filled with a liquid. When the vessel is rotated about its own vertical axis, half filled, the liquid rise up to near the wall. Half filled, the liquid rise off near the wall. Okay. If the radius of the vessel is 5 centimeter and its rotational speed is omega 2 rotation per second, then the difference in the heights between the center and the sides. Okay, let me do it. I'm here is English, huh? So you have a vessel, and they say now half filled. Okay, half filled. So if this total height is, let me change the marker. Where is the marker? Maybe outside. Oh. Then I have to pour the ink actually, or I have a blue marker also, but yeah, I have a blue marker also. Use that. So okay, let me discuss this question, then I will. So total height is h, and let me say this is h by 2, complete liquid, and they are saying when the vessel is rotated about its own vertical axis, it is rotated, and the angular speed is 2 rotation per second. So omega is equal to 2 rotation, 2 into 2 pi, that is omega is 4 pi. If the radius of the vessel is 5 centimeter, this is 5 centimeter, then the different water liquid near the wall. Vessel is rotated about its own vertical axis, the liquid rises up near the wall. So the liquid rise up near the wall like this. Okay, near the wall, and now they are asking us to find difference in height between the center. So this difference in height they are asking. So do you remember one formula? If you don't remember, I have to derive it. So let me derive it. So when I rotated the vessel, the liquid form is shape like this. I don't know the shape, I will find it, but let's say it is making some shape. So let me take a point here, and what is the pressure here? Now pressure at this point is P0, and we know that pressure P here, as it is rotating, it has a acceleration, that is omega square into r. R is this distance. So because of the rotation, the pressure will be A acceleration density into dx integration or here dr integration. If the acceleration is not depending upon distance, then you simply write rho a into delta r or r, like this you can write. But here the acceleration is changing. Here the acceleration is depending on distance, so you have to integrate this. So if you integrate this, acceleration, in place of acceleration, let me write omega square r dr, and from 0 to r you will get rho omega square r square by 2 is the acceleration, is the pressure. So pressure here becomes P naught plus rho omega square r square by 2. But if you look from this side, if this height is h and pressure here is atmospheric pressure, if I go downward, then pressure becomes P naught plus rho z h, and these two must be equal. So you got h must be is equal to omega square r square by 2z. Now let me consider this point. Now here r you have to take 5 centimeter, convert it into meter, omega you know, and this height capital H you can calculate, no problem. Omega you know, r you know, h you can calculate. So let me pour some ink and I will again continue. Please comment everything is clear or not, or any doubt. If you have any doubt. What is the ink? Do more. It is of fluid mechanics. Yeah, of course it is from fluid mechanics. I know it is out of syllabus of this week. Oh. Sit. What to do is it's very difficult. Yes. Oh, already ink actually came to my head. Hmm. How you people do this kind of thing, yeah? In class? Okay. So, sir, please increase clarity of video. I cannot increase clarity. So let me see the clarity. Oh, it's little bit. For now, we have to see. Next time, I have to connect my DSLR with the computer or with the phone. I have not. Everything is locked down. So to connect my DSLR with this thing, I need a cable, and for that, so right now we have to, after the lockdown, if they may increase, then we can use some better technology. But for now, let's manage. Huh? For now, let's manage, or I let me take this thing little bit further, so it may be little more clear. Mhm. I think little bit more clear now. Maybe. Yeah. So okay. Okay, so continue. So next question. Uh, Question number 8 is completed. Now 9. A Carnot a Carnot engine operating between temperature T1 and T2. One second. A Carnot engine operating between temperature T1 and T2 has efficiency 1 by 6 when T2 is lowered 62 Kelvin, its efficiency increases 1. So you know efficiency, this is also out of syllabus I think. Carnot cycle is 1 by T2 by T1 and its efficiency they gave us 1 by 6, and when the temperature is, that is T2, when the temperature T2 is increased, T2 is lowered by 62 Kelvin. So when the temperature T2 is lowered by 62 Kelvin, T2 minus 62, and then the efficiency becomes 1 by 3. Solve these two equations and you will get your answer. Okay. So solve these two equations and you will get your answer. Next question. Combination of capacitor. Oh, this is from 12th. I don't know you know capacitor or not. So let me skip this one. And 11th is also not from your topic potentiometer. 12. An express current moving at 30 meter per second reduce its speed to 10 meter per second in a distance of 200 meter. If the braking force is increased in the beginning, find the distance that it travels before coming to rest. So, a train was traveling at a speed of 30 meter per second and its speed has decreased to 10 meter per second, right? In 200 meter, its speed has decreased to 10 meter per second. Now, if the so deceleration is a, you write v square minus, so now final velocity v square is equal to u square minus 2a into 200. So you got the value of a, and when the braking force is increased to 12.5%, is increased by 12.5% in the beginning. So now the acceleration a becomes 12.5%. So 1.125 a in the beginning. Then find the distance that travel before coming to rest. So now deceleration becomes this, and initial velocity is 30. Finally, it is coming to rest when final velocity is 0. So write 0 is equal to u square minus 2 this acceleration 1.125 a into distance is s. Now using these two equations you can calculate s. Next question. 15. 13. A stone is dropped from the top of a tower, traveled half of the height of the tower during. Already I solved this. Don't know, sir. What don't know? Already. Oh, okay. That capacitor thing. Yeah. So already I solved question number 13 in WhatsApp. But let me. So do you want 13, 14, 15 again? 15 I think you want. That is from center of mass. And 13, 14 if you want you just type 13 you want or not. Stone dropped from the top of a tower. What? Capacity. A stone is dropped from the top of a tower. Travel half of the height of the tower during the last second. So, a stone is dropped from the top of a tower. Total height is h. It traveled half of the height, that is h by 2, in the last second. So, total time taken if it is t, and this is 1 sec in the last second. This time is taken 1 second, or it is covering this much path is t minus 1 second, and it is covering total path in t second. So for this, let me write total distance covered s is equal to initial velocity is 0 half z t square. For this leading light, total distance covered h by 2 is equal to initial velocity 0 into half z t minus 1 square. So this is one equation, this is one equation. Solve it, get it. Next one, 13th, option 3 or 4, sir. I don't know, you solve it. These two equation I already gave it to you. Solve it, 3 or 4. Ah, okay. Next. Okay, 2 minus root 2 and 2 plus root 2. Are you getting two different solution? Okay, let me solve it then. So, h by 2. So, in place of half z t minus 1 square is equal to h by 2. So, 1 by 4 z t square. Z cancel. Let me take 2 this side. T minus 1 square is equal to t square. So, root 2 t minus 1 is equal to t. So, root 2. Oh, solve it. What will you do? Root 2 minus 1 is equal to root 2. So, t is equal to root 2 by root 2 minus 1, then root 2 plus 1, root 2 plus 1. So, is 1. So, root 2 plus 1. 2 plus root 2. Type t plus root 2. Okay? 2 plus root. Option 4. Question number 14. From a point on the ground at a distance of 2 meters from the chord of a vertical wall, a ball is thrown at an angle of 45 degree. Let me erase this one. So you have a wall here and this distance is 2 meter. This distance is 2 meter. And the ball is thrown at an angle of 45 degree like this. And then they are saying of which just clear the top of the wall and afterwards strikes the ground at a distance of 8 meter. Height of the wall. Achha. So it just clear the top of the wall. This is the top of the wall, and then it go another 8 meter. So from this it is clear that range is 10 meter and angle is 45 degree. Now they are asking me height. I know equation of trajectory x tan theta 1 minus x by r. Tan 45 is 1 and range is 10. Now when x is 2 meter, what is the value of y? Just put in place of x 2 and get the value of y. Next, 13th option 3. Okay. Next, 15th. Bomb at rest at the summit. Okay. Bomb at rest at the summit of a cliff. The summit of cliff breaks into two equal fragments. One of the fragments attain a horizontal velocity of 20 root 3. The horizontal distance between two fragments when their displacement vector is inclined at 60 degree relative to each other. So equal fragment 20 root 3. Okay. So this is a cliff and the bomb has, and okay, forget about this thing. So okay, let me just draw a line like this. Now here it breaks into two equal fragments and one fragment move with a velocity 20 root 3. 20 root 3, yeah. One fragment moves with velocity 20 root 3 like this. And due to conservation of linear momentum, masses are same. So another fragment also move with 20 root 3 like this. Now what they are asking? Now they are asking us to find horizontal distance between two fragments when their displacement vector is inclined at 60 degree. So displacement vector, not velocity vector. Its velocity for now, let's say it is going like this. But the displacement vector is this one. And again it is similar path it is taking. And here the displacement vector is this one. So this angle must be 60 degree. That means this one must be 30 degree. So this distance x and this height h, tan 30 must be is equal to x by h. But how much distance it cover? u times t, x is 20 root 3 times t, and how much time it is taking? S is equal to half zt square. Right now, because it is u initial velocity along y direction is 0, acceleration is g. So tan 30 is equal to 20 root 3t by half zt square. That means you got the value of t. You got the value of t. That means you got the value of x. And they are asking us distance between these two things, horizontal distance. That is 2 times this distance. 40 root 3 into t. Find t from here. Next one is 16th one. A man can swim with a certain speed in still water to cross a river to a point directly opposite to the starting point in time t naught. Okay. So, so here a man can swim and he will reach directly like this, just opposite bank. This is 90-degree, and time it is taking is t naught when the man can swim with constant speed in still water. Okay. T naught. When the river flows, it crosses the river the same path in time t1. Okay, when the river is still, that means the river is not flowing, it is taking t naught time. If its velocity with respect to river is vr, so here the river is still, river is not flowing and it is taking t naught time. So t naught is equal to velocity equal to distance by time. So time is equal to distance d by velocity vr. Now in the second case, again the river is flowing with a velocity u, but here it was 0. So the swimmer wants to go in the same path. So drift must be 0. Swimmer is going in the same along the same path. So it is making some angle theta with the river. So it is going with Vr cos theta, and this is Vr sin theta. So this Vr is velocity of the swimmer relative to water. So velocity of the swimmer relative to ground is Vr plus u. So when I am looking from ground, I will see its velocity is addition of this plus this vectorically. So these two cancel. According to quotient, it is moving along the same trajectory, same path as this. So that's why Vr cos theta, and time it will take is d by Vr cos theta. That is t naught and t. So what is the question? Let me see again. Now they are asking us to find if d is the river width, then the velocity of water current. U they are asking us. They are asking us u. So we know these two equations. You can solve it from this equation. So t naught is equal to, let me write it, d by Vr. Next equation, t is equal to d by Vr cos theta. Next equation, u is equal to Vr sin theta. You just solve it and you will get it, or let me solve it otherwise if you feel any difficult. D by Vr is t naught by cos theta. From these two equations I got t. Now they are asking us to find u, and u in the form of t naught and d. So u is equal to Vr sin theta. What to do? Now Vr sin theta na. So let me write Vr is d by t naught, and sin theta is 1 minus cos square theta, and cos square theta, or Vr 1 minus cos square theta. Let me take Vr inside, Vr square minus Vr square cos square theta. Now let me write here. So u is equal to root over of Vr square is d square by t naught square, and Vr cos square theta is d square by t square. So if I solve it, I will get d by t naught t and t square minus t naught square root over. So let me go through the option. That is question number. So you just find out option. Everything is clear now. Please comment once. Next question number 17. Let me see how is going. Please comment once everything is good yet. Okay. How many of you are here? 16. So 17 one. A car accelerates from rest at a constant rate alpha for some time. After some time, it decelerates over beta. If the total time is t, then displacement of the car is okay. So a car is moving with a constant acceleration alpha tan theta is equal to alpha, and again it is going such that this is phi tan phi is equal to beta. This is a velocity time curve. Now here let's say maximum velocity is v naught, total time is t. Let me draw a line like this. So if this time is t1, then you will write v naught must be is equal to tan theta is equal to v naught by t1, and tan theta is alpha, so v naught must be alpha t1. Similarly, if you go through this triangle, tan phi, that is beta, is equal to v naught by t minus t1. So you can write v naught is equal to beta time t minus t1. One equation you got it. What they are asking us, total displacement is nothing area under VT curve, and area under VT curve is height is v naught into base t by 2, but v naught, okay, alpha t1. So let me find out relation between t and t1 from these two equation. Alpha plus beta t1 is equal to beta t. So t1 is equal to beta t by alpha plus beta. Now v naught is alpha t1. In place of t1, let me write beta t by alpha plus beta. Many of you know this question and already solved this question, but still maybe some of you have not solved. For them only I am solving it again. So in place of v naught, you write alpha beta by alpha plus beta into t, again t square by 2. So next is a rod of length mass f1 and f2. F2 is less than f1 as shown in figure. The tension of the rod at a distance y. Okay. So this is your rod, and your force F1 is acting like this, and your force F2 is acting like this. Length is L. Take this rod as a system. If you take this rod as a system, what is the acceleration? Acceleration of the system F1 minus F2 net force along x-axis by mass. So acceleration of the system is F1 minus F2 by mass. Let me write linear mass density into length is total mass of the rod. Now the tension in the rod at a distance y. So now let me consider a point at a distance y. Now let me consider this total as a system. So now your system is only this part is your system, and this distance is y. What are the forces? One is F force acting here, and other one is tension acting due to the other part. And acceleration already we calculated. So we will write F minus T is equal to mass of this part into acceleration. Mass of this part is lambda times y. Lambda is linear mass density, and acceleration we already calculated. F1 minus F2 by F1 minus F2 by lambda L. Lambda lambda cancel. Now just solve this and you will get the value of T. Next one. Plant in a block is resting on an XY plane, and the coefficient of friction between the block and the plate is mu. The plate begins to move. The block is resting on a horizontal plate, and the coefficient of friction between the block and the plate is mu. The plate begins to move in the x direction and its velocity v bt square. V time and v being a constant. At what time will the block start sliding the plate? So, you have a plate like this and you have a block like this. Now this plate start moving with a velocity v is equal to vt square. And now here mg is acting, normal force is acting, friction is acting. Now there is a relative motion is going on, or tendency to relative motion is there, because the block is in rest and the plate is trying to move right side. So the block is, so there should be a relative motion, but friction, what is the work of friction? It will oppose the relative motion. At least it try to oppose the relative motion. So as there is a relative, there is a relative motion. So what the friction will do? Friction will act this side to oppose the relative motion, and the limiting friction is mu times z. So what is the acceleration of this one? Acceleration of this one is dv by dt, that is 2bt, right now. So up to, so let me see here, one second. So this is marker in my hand. If I am right now moving the marker, but marker is not falling because mu is sufficient to keep the marker in my hand. But if I move my hand rapidly, then, or you can think like that, if I move my hand very fast, then duster will fall, because now friction is not sufficient. Now friction is not sufficient to, right? Everyone is there, right? What's going on live now? Yeah. So what I was saying is, yeah. So forget about Vt square. Let me consider just a normal case. Then I will go to this question. So this is going with an acceleration a. What is the minimum value of a, so that if for that acceleration the marker, the block will not, there will no relative motion, and if I increase the acceleration from that value, then there will be relative motion. So so acceleration is a, so if this is m and this is m, so you can write, so the small mass is moving towards right only because of friction force, and the friction must have its value ma, then only the small mass has the same acceleration a, and there is no relative motion. Phone was coming actually, so that's why. One second, let me tell. Just one second. Sorry, guys. What is the question? on. Actually, I am taking live classes, sir. So I already sent you a link also. You can follow. So just I will call you after 5 minutes. Hello. What is the question? YouTube. Where is YouTube? Okay, everyone is there now. There is a disturbance. There was a disturbance. Sorry. Oh my God. Hello. Sir, actually I am taking live classes. I already sent you the link also. You can follow. After that, I will call you, sir. Oh. So actually, I am taking a Bagdevi campus live classes. So I don't know. Just I gave you the link also. You just send them the link. They can also. I was discussing questions. Okay, I am just giving the link also in 1 week. Bye. The student once again. Sorry. What is 1 week? Oh, my phone battery is. I have to charge it. Otherwise, it's difficult. Just wait 2 minutes, guys. Please. Like this. I will continue again. I'll continue again. So you can just say everything is how is going on your studying in your home or not. Hmm? Okay. And the question paper also let me forward to them. What is the question paper? This is the question paper. Forward. How to forward? So, 1 week. Difficult. Vagdevi. Question. Okay. Okay, let's continue now. Again, sorry for the disturbance, guys. I will again let me resume it. So the question is, where is? Yeah. So actually, I am discussing a question paper. If anyone is joining now, that is for junior student, 11th class student, Bagdevi campus. And I already sent you. If 1B student is joining here right now, then for them I already which question paper I am discussing. I already sent you the link. So sorry, I forgot 6 to 8 was your class, but I already timed. So I'm very sorry for that. So question number 19 we are discussing, and in question I erase everything. So in question number 19 the thing is that this is a block of mass m, and what to do now, this is a plate and the plate is moving with a acceleration a. What should be the minimum value of acceleration so that the block there is no relative motion? So for this block to move forward, a friction is giving the force, and the friction for this block, as the block is moving with acceleration a, we can write F is equal to ma, where F is the static friction. But this static friction must be less than limiting friction, that is mu small mg, and static friction is ma. So when a less than mu g, this a less than mu g, there is no relative motion. But if I increase this acceleration of my hand more than mu times g, then there will be a relative motion between duster and my hand. So in your question, velocity was b times t square. That means acceleration you can calculate 2bt, and when the relative motion will start, when this condition, oh my god, sorry. Uh, so when this mu z, I mean when this acceleration is greater than mu g, then relative motion will start. So when 2bt is greater than mu g, so time you can calculate mu z by 2b, then relative motion will start. Next one, 2b, if 1b student are present, for you guys also I will take live classes tomorrow. Tell me which topic you want on your comment box and I will take live classes like this. Okay, so now which question? Question number 20. Two bodies A and B of mass m1 and m2 loaded to a massless string at different point, rotated along a concentric circle in horizontal plane. The distance A and B from the common the tension it is. So next question you have a spring like this, and then I have to you have a spring and they are saying the tension is, sorry, oh my god, engineers. So you can see what happened to my hand. So this happened when you stay alone. Okay, so your question is, two body A and B masses are m1 and m2, and from common center are 50 centimeter. This one is 50 centimeter and this one is 1 centimeter, and they are saying the string A and B are in the ratio 5:4. Tension. This tension is 5 T naught, one is 4 T naught, and they are asking us to find masses. So if it is m1, so omega are same, so omega is same, so m1 omega, what is the value of tension? 5t1 is equal to m1 omega square 50, okay, and 4t0 is equal to m2 omega square, 1 centimeter means 1. So divide it and get it. Next question 21. So as shown in the figure, card mass m1 m2, where acceleration of the card, okay, m1 m2. So next question is, you have a card like this 21, and then this is attached, and one is m1, other one is m2. They are asking acceleration. You know how to find, first find out the constant equation. So if this is A and this is capital A, this is T, this is T, this is T, so this must be 2T. So 2T into capital A minus of 2T into capital A, T1 dot A1, already I discussed T1 dot A1 plus T2 dot A2 dot is equal to 0. So 180 degree minus 2T into A into T into A plus T into A is equal to 0. So A must be is equal to 2A. Right. Now equation you will get m2z minus 2t is equal to m2a, and t is equal to m1 into capital A is 2a. Solve these two equation and you will get it. Next question 22. Transistors are for CO1B. Okay, sure. 1 meter. Okay, then take 1 meter. 22. A particle of mass m is made to move with uniform speed v along the perimeter of a regular polygon of 2n side. The magnitude of impulse applied at each corner of the polygon, okay, sine pi by vn, is amv. Okay, so your next question is, you have a polygon like this. Okay, now in this polygon, velocity they gave us is v, uniform speed v, and 2n side, so sides are 2n, so 2n side mean this angle theta must be 2n time theta must be 2 pi, it's clear. And then impulse applied, so impulse, this is your speed v and this is your speed v. So impulse is change in momentum, so m times change in velocity and change in velocity. So to calculate change in velocity, what is this angle? Initially it was going like this and now it is going like this. So what is this angle? Now this angle is, this is 180 minus theta by 2, and so this angle must be, just 1 second, so follow the geometry. Let me do a hexagon for this. Now for hexagon, and we know, so this angle must be your okay, let me calculate this angle, then this angle we can calculate. So this angle is 180 minus theta, this angle is theta by 2, and again this angle is also same, 180 minus theta by 2. So this angle must be 180 minus 2 times this two angle, 180 minus this thing, theta by 2. So simple, this angle is coming is 2 to cancel power. This angle is theta. So as this angle is theta, so your change in velocity you can calculate v square a square plus b square minus 2v square cos theta, and v take it outside, 1 plus 2 cos square theta, 2 cos theta, right? So 1 plus 2 cos theta you can write cos square theta minus sin square theta. So the 2 take it common, 1 plus cos theta, cos square theta minus sin square theta, and you will get 2 cos theta by 2. This is your change impulse for this thing. So impulse you got it, now solve it yourself. Now question number 23. Two small spheres each of mass 3m connected by a string of length 12 are kept on a smooth horizontal surface. A vertical force F is applied at the middle of the string. What is the maximum value of F for which the sphere do not lose contact with the surface? X mg, then value of X. For what value of F? Maximum value of F for which the sphere do not lose contact with the surface. Two small spheres of mass 3m connected by a string of length 12. So next question number 23, you have diagram is like this and total length is 12, that means this is L, this is L. If force acting like this, so tension must be T and T. They are asking maximum value of F so that the ball will not lose contact. So when the ball will lose contact, when normal force become 0, at that time the ball will lose contact. So this angle, let me write theta, they gave us here theta. So this angle they are taking theta. So this is T cos theta, and this is t sine theta. So when will the ball lose contact? So t sine theta is slowly increasing, because initially only when force was acting, t was acting like this, slowly it is getting upward. So and slowly normal force was decreasing. At a certain point normal force becomes zero, and from that point it will move upward. So just let me consider at the point when normal force becomes zero, t sine theta is equal to mg. At that point, this is again t and this is again t. This is 90 minus theta, 90 minus theta. So t sine theta, again 90 minus theta, so t sine theta. So f must be is equal to 2t sine theta. So in place of t sine theta, put f by 2 is equal to mg. So f maximum value f must be 2 times mg. Now 24. Time varying force F is equal to k naught T is applied on the block of mass M placed at rest on a rough horizontal surface. Time varying force F is equal to k naught T is applied on a block of mass M. So a time varying force F is acting on a block of mass M, so that the force is k naught times T. Force is k naught times T. Now placed at rest on a rough horizontal surface, and coefficient of friction is mu. T equal to 0, the acceleration of the block is given by P mu z. At time t is equal to 3 mu mz by k naught. The acceleration of the block is given by P mu z, by P mu z, where P k naught is positive constant, F is equal to k naught T. So now what a acceleration you have to find, but it is very simple now. F net force k naught T must be is equal to m into a coefficient. Friction is also there, right? So friction is also there, and this F is acting horizontal, so friction is acting like this. Now, initially, when the force becomes, your acceleration must be m times a is equal to k naught t minus mu mz, and your acceleration is k naught t by m minus mu z. This is nothing but dv by dt, and then you will write what to find. What are they asking? No, acceleration is mu mz. At a time t they gave us, so at a time t is 3 mu mz by k naught minus mu z. So k naught cancel, cancel, this is 2 mu z. So P is 2. Very simple question they gave us, you not complete. All our questions are simple. I think mains examination, that's why. So complete discussion completed. Please comment about it. I know there was little bit disturbance, but next time in few days this will, when the fluency will come, because your country is uncertain, not country, world is in uncertain mode, and but that doesn't mean that we have to do something. That doesn't mean that we cannot sit ideally, right? So the world is in uncertain mode, but we have to learn ourselves, we have to grow ourselves in the period. Your mains and advanced exam will happen this time or not, we don't know, if the senior students are watching for them. But thing is that you take it as an opportunity. First of all, don't go out from your home. It's very important. If someone else, your brother, your sister, or your parents are also going, then it is very much says advisable to not to go out of home for now, and in this time don't waste this time, use this time. Many people may waste their time, but if you use your time properly, then sorry, someone is calling, I'm very sorry. So that's fine. That's what I have to say. Everything will come usual, and use your time properly and study as much as you can. Thank you. And please comment. How was it? Everything. Please comment. Not. Please comment before. Yeah. Finally, please comment. Everything was good or not, and then I will end it. 2 minutes I am giving you to comment something about it. How many of you are still present? 16. We got good clarity. Thank you, sir. Oh my god. Okay, then I think I have to end it here. I am getting many calls and okay. Thank you. Be safe. Study well. Bye bye.